Hello everyone, this is your captain speaking. Welcome back to my channel, and this is my first edition of making a video on the meteorology, and I would be starting from the first chapter, that is atmosphere. So before starting this video, I would just want you to know that this subject is in fact very easy. You don't have to put a lot of brains in it. All I would want you to give is your focus and your ears, because whatever I'll speak, I would want you to hear it very clearly, and you can answer your questions in the comment box, and that is how I would just get to know if you're getting all the things or not. Yes, good to go. Let's get started then. So this is your very first chapter, that is atmosphere. So atmosphere, okay, I'll start from the very first line, that is important also. It says atmosphere is an envelope of homogeneous mixture of gases called as air. So atmosphere is nothing but the envelope of gases, envelope of homogeneous mixture of gases. So let me just show you what all gases are there. So as you can see, these are all are the gases that the atmosphere constitutes of. These are the most important gases. These are the most important gases, and these are few traces that are found in the atmosphere and not very important. As you can see, the most important ones are given with the values of how much they are present in the atmosphere is what you have to remember, because in exam it would come like the values would be given and you have to choose which one is what. Okay, so this is one important thing. Other than that, let me just highlight you one more thing, that is due to gravitation. So there are millions of molecules that are present in the atmosphere. So one thing that you have to focus on is that the higher concentration of molecules means the heavier molecules are at the lower level and the lighter molecules are at the higher level. This is something that is very important and would be helpful in the next 4 to 5 chapters. So this is something you need to know, that air surrounds the earth and is attached to it due to gravitation. Now there are two spheres, basically the homosphere and the heterosphere. So the homosphere constitutes actually homosphere goes till 80 kilometers, and after that there's heterosphere. In homosphere there's troposphere, stratosphere, mesosphere. Okay, that is something that is too deep in. We'll move to it in the next video. I mean, not the next video, but like later on. Okay, let's move on. So in the first page, we have to look for you should know what atmosphere is. You should know the values. Okay, now the next page. It is the ratio that is given. Nitrogen is to oxygen by volume and nitrogen is to oxygen by weight. So you must be thinking that how to remember this, because this is very important. As you can see, it is also highlighted with like dark font. So you can remember this by weight, that is 3:1. So if you invert the W, it goes like 3. So that is something you can remember. Other than that, that would be volume. So now the next thing, that supplementary oxygen is needed above 10,000 feet. Okay, so there is a need of oxygen supply when we move at the higher altitude. You must have observed it when some climber, some people, when they go climb Mount Everest or some mountain, they carry oxygen cylinder with them, because the oxygen value decreases when we move upwards, and that is above 10,000 feet. Okay, now as I mentioned before, the whole atmosphere is divided into two, that is homosphere and heterosphere. Now you read this: atmosphere is generally well mixed. It has nearly similar composition except for ozone. Okay, we'll read about ozone. Up to height about 80 kilometers due to gravitation. The atmosphere up to 80 kilometers is homosphere, very important, and above it is heterosphere. Okay, now moving on to the next. Now variable gases are not very important. You can just give a read on what all gases are there. Okay, now moving on to something that is really important, that is greenhouse gases. So greenhouse gases leads to that leads to global warming. So before knowing what global warming is, I would want you to know what greenhouse gases is. Now focus on this, very very important. So this is the sun. It radiates its heat towards the ground. This is ground. Towards the ground, the ground gets heated very much. Later at time, this heat is released in the atmosphere. So there are molecules which are gases that trap the heat in the atmosphere and does not let it escape in the space. So when the heat is trapped by the molecules, so for example, one more, suppose for one day the atmosphere is something like 29. Okay, now this again process will happen, and for example the temperature was 29. It did not, this molecule did not let the heat escape. So again this process will happen, again it will trap the molecules sorry, again it will trap the heat. So this will become some 32. This keeps on happening and it keeps on increasing, then 35, then 39, and again with time it keeps on increasing. And these are the greenhouse gases that leads to global warming. I hope you understand. So you can see these are the greenhouse gases, that is carbon dioxide, hydrogen, water, methane, that is CH4, and ozone. I hope you understand. Now moving on to the next, that is dry air and saturated air. Well, we'll read these topics in the coming chapters, but we can just give a read on this. So it says that okay, from this part, okay, from here, the concentration of water vapor rapidly decreases with height. Okay, the water vapor content in the air depends on the temperature. Warmer air can hold greater amount of water vapor. So basically water vapor is you can say the moisture that is present, the humidity that is present in the air. So for example, if we talk about, okay, wait, well, sorry for that. Okay, so well, if we talk about Mumbai, so Maharashtra is like near the sea, so it has larger content of water vapor. But as we move up with height, it gets colder, so less warmth is there. So less warmth is there, so less water vapor content would be present. That is why it says that water vapor content depends on the temperature. You can just relate it with how the temperature is in Mumbai as compared to how the water vapor content is there in some hill station like Darjeeling or some hill station. Okay, so now the most important another thing is this, that the air can hold only 4% of water vapor. All right, and this is saturated air. When it, like for example, if the atmosphere is completely containing 4% of water vapor by volume, then it is saturated air. It means it cannot hold much more water vapor in it. All right, well, these are the topics. Well, these are a few terms that you might not understand, and you can just go to my another video and check out what all excuse me, what are all these. All right, well, this is the first chapter, so this is some basic knowledge that you need to grasp is these values. That's it. Moving on to the next page. Now something that is not important, you can just give a read on it. Now something that is very important, ozone. This comes every time, so we'll just read. Ozone forms in the upper atmosphere. It absorbs ultraviolet radiation from the sun, raises temperature. O3 molecules then become heavier and sinks accumulate in the lower level. Ozone protects us from the ill effects like skin cancer, sunburn, and cataracts of UV rays. All right, and this is present in the 10 to 15 kilometer, and the maximum concentration is at 20 to 25 kilometer. So before letting you understand all of these, there is something most important that you need to understand is this. I'm sorry for it being not very organized now, but it can help you. So this is what are the layers of atmosphere. So starting from the troposphere, then there's tropopause, then stratosphere, then stratopause, then mesosphere, then mesopause, then ionosphere. This is ionosphere. No, you don't see this one, but thermosphere and exosphere. The last is exosphere. So for your better understanding, you can see this picture where you can see that ozone layer is just present beneath the stratosphere, and if a question comes that ozone layer is present in which sphere, so that is stratosphere. All right, so what usually happens is that there are CFCs, that are chlorofluorocarbons, which are used as a fire extinguisher, but the use of it is banned now because it creates a large hole in this ozone layer, which lets the UV rays to enter to the earth, which can cause us the damage. As we read before, these are the ill effects of the UV radiations that ozone protects us from. So because of these CFCs and all halo refrigerants, it causes us these. So that is why the use is banned. This is something that you should just go through, not very important, just for your information. Now moving on to next, this is very important. So due to gravitational attraction, the approximate distribution of air mass with height is, so below 6 kilometer this much air mass is present, below 10 this much, and below 35 99% of air mass is concentrated. Please remember this, it is important. So well, in exam it can come like, at what height the half of the air mass is present. So half is this 1/2, so it would be 6 kilometers. All right, now moving on to the next page. Now coming to a topic that is very important. So this is, wait, I'll just set it up. Yep, so this is thermal structure of atmosphere. So well, there are two kinds of heat, that is sensible heat, and then there is latent heat. So sensible heat is the heat that we can sense. So if you see, conduction is there, convection is there, radiation is there. So we'll read this one by one, what all of these mean. This is something that is very helpful to understand all the three terms. So starting from the conduction. So conduction is heat is transferred by the molecules. So for example, if this whole thing is heated, so the heat of this cup that is in contact with this, so this will also heat up the handle, that is conduction. So conduction is when the molecules are transferring the heat, is conduction. Now moving on to the convection. So convection is when for example, these are the molecules that are heated up, the molecules that are the lower surface, that will be heated up faster. So as the temperature increases, the density would decrease. As the density decreases, it has become lighter, you can say, less heavier. So this will move upwards and the heavier molecules will move downwards. So the molecule starts changing its place, and that is how the heat is transferred. Got it? That is what convection is. All right, now moving on to the third one, that is radiation. So radiation is wait, I'll show you something that you can connect to radiation. So radiation is we can understand by this picture itself. So radiation is when the heat waves that are transferred from the stove, I guess this is called stove only, I guess, yeah, whatever. So this is when the heat waves are radiated. Well, I'll show you something that you can connect with what exactly happens in the atmosphere. So this is what happens in atmosphere usually. This is the sun. The radiation, the heat is radiated by the sun in form of waves to the earth. So when the when the surface gets heated, then the hotter molecules becomes less dense and it rises up, called as convection. And convection, yeah, that is convection. And conduction is when? Well, before convection is only happened, then convection happens. So conduction is when the heat is transferred in the like to the other molecules. The like for example, if one molecule gets heated, then it will convert its heat to another molecule, and that is how the whole earth gets heated. And then the heated molecule will rise up, that is convection. So you should remember, first radiations happens, then conduction happens, then convection happens. This kind of heat is called as sensible heat, that is only 23%. Now talking about the latent heat. Now latent heat, if you see, has the largest number of largest in percentage, that is 77%. So this is evaporation, condensation and sublimation, which means that these produce the largest amount of heat. So well, evaporation is something that we've been studying from our childhood, these all three terms, but still I'll show you something that is very important. This is my notes that I used to make when I was in ground class. So you can see if this is, yeah, when it becomes if you see that if it converts from solid to gas, this process temperature is decreased, and in this process temperature is increased, warm, the atmosphere is warm. So you can just go through it and remember, because it is important for your knowledge. All right, now talking about the layers of the atmosphere, you can see these are the layers. And tropopause separates stratosphere and troposphere. Stratopause separates mesosphere and stratosphere, and mesopause separates thermosphere and mesosphere. You can see thermosphere is only till 80 kilometer, and then there's heterosphere. And ionosphere is starting from the mesosphere to the exosphere. All right, now moving on to the next. Yeah, so getting back to these two first. So latent heat is basically the heat that is released during the change of state of a object or of a body, basically. So that is what latent heat is, and it is the it has the largest percentage of 77%, and these two values are very important to remember. Now moving on to the layer, you should remember each and every layer. Now we'll read about each and every layer in a depth. So let's get started. Starting from the stratosphere, we'll read one by one. So stratosphere is the lowest portion of the atmosphere, like it is the lowest portion, it is the lowest layer of the atmosphere, and it extends from the surface of Earth to the height of 16 to 18 kilometer from the equator and 8 to 10 kilometer from the poles. Very important line. So the stratosphere has a different height at the equator and at the poles. The cause of higher height at equator is rising hot convection current. In this layer, the ascending hot air gradually cools and I'll let you know. This is again from my notes. So as you can see, this is the equator. Okay, wait. Equator is somewhere here. Oh God. Okay. Equator is somewhere here. So you can see as we go up, the temperature decreases. That is why it gets cold at the hill stations. All right, so you can see at the from the equator to 16 to 80 kilometers, the temperature would decrease. But something very important that you have to focus, that at 10 kilometers the temperature starts increasing after the 10 kilometer, because the difference at the equator is that at the equator the tropopause would end, the troposphere would end at the 16 to 18 kilometer, whereas at the poles the troposphere would end at 18 to 10 kilometers itself. So something very important that I would want you to focus on is, seeing this, you can see that first the temperature decreases, then increases, then decreases, then it would increase. meaning that the temperature, as we move forward, the temperature would be decreasing. It means it would be getting colder, but as we increase in the stratosphere, but as we move up, the temperature would be very hot. Again the temperature would start decreasing, means cold, and again the temperature would be very hot, very heated atmosphere, and after that there would be no atmosphere, that is exosphere. So this is the cycle of the temperature. Again, moving to this video picture, you can see that the temperature that the stratosphere will start after here, and the stratosphere will be starting here after 8 to 10 kilometers. All right, we'll when we'll solve questions more, it will get clear, so you can just keep this in mind at the first place. All right, so these are the two values at the rate at which the temperature decreases. So 2 degrees Celsius per 1000 feet and 6.5 degrees Celsius per kilometer. You can see the term lapse rate. So lapse rate is the rate, basically lapse rate is the decrease in temperature with increase in height. Hear me again, the decrease in temperature with increase in height. As we move up, the temperature decreases, that is lapse rate. So lapse rate is this, and so there are two types of lapse rate basically, the negative lapse rate and the positive lapse rate. The positive lapse rate is that positive, it is working as it is, the decrease in temperature with increase in height. But negative lapse rate is when the temperature would increase with increase in height. That happens in, I want this answer in the comment section, okay, but I would just tell you, because this is the first time you all are studying this chapter. So this happens in stratosphere, the increase in temperature with increase in height, as I showed you before. Wait, I'll show it to you again. The increase in temperature with increase in height, this is negative lapse rate. The decrease in temperature with increase in height, this is positive lapse rate. All right, you can just read this, not very much important stuffs are written, but if you don't understand any of these lines, just comment down below, I'll just explain that in it. All right, so you can see there are 3 types of stratosphere: upper, mid, lower. Not very important, you just read on it. Okay, these are very important, which are highlighted, which is warmer the surface, higher is the height of the tropopause. Can you connect this line? I'll again show you the picture. Right, read it again, reading it again. Warmer the surface, equator is warmer, higher the height of tropopause. You can see the tropopause height is at the higher, but if you see here, the tropopause will meet at a lower height, but at the equator the tropopause will meet at the higher height. That's it. It's easy, not very hard. Let's move on to the next page. Moving on to the next topic. Wait, we'll just see this out once again. So you can see lapse rate is 2 degrees Celsius. Okay, wait, this is for tropopause, but for troposphere, yeah, but for troposphere it was 2 degrees Celsius per 1000 feet and 6.5 degrees Celsius per kilometer. All right, this is not very important, you just read it. All right, very important again, there is a reversal of temperature and density above 8 kilometer. Very important relation, I will let you know once again. Wait, as the temperature increases, the density would decrease and the pressure would decrease. You can relate this from the convection, when I told you that when the lower molecules were heated, its density was lighter, so it moved upward. So similarly, from that you can remember that is how it works. Pressure also decreases. So here it is written, you can again see the example of this. Here it is written, there is a reversal of temperature and density above 8 kilometers. So according to this, you can see the temperature is decreasing at the equator, but there is reversal. This is 8 kilometer, 10 kilometer. All right, you can see 8. All right, So at the 8 kilometer there is a reversal of temperature. It means the temperature would increase and the density would decrease, but here the density would increase at the equator. The density would increase here, the density would decrease here. It's inversely proportional. Please keep this in mind. Alright, moving on to this again. So this is not very important, but you can just read all of these. These brakes, force, jet streams are few topics that we'll be covering in the next coming chapters. Alright, so these are the types of tropopause. You can just go through: polar, tropical, middle. Alright, remember the pressure, the over India it is found at, okay, the height, it is the temperature, the height, and the pressure. Alright, okay, moving on to stratosphere, another important layer. So we'll just read it. Stratosphere extends up to 50 kilometer from the Earth's surface. Alright, so it will start from is at the, like, it ends at the 50 kilometer from the Earth's surface. For example, if this is the Earth's surface, till this 50 kilometer is stratosphere. Alright, now here it is written that this layer initially is isothermal. So one thing very important that you have to remember is the word iso, that will be used in the coming chapters too. So iso means constant. So iso, constant thermal, is temperature, which means constant temperature at 8 to 10 kilometer in stratosphere. It means that before the starting of stratosphere at 8 to 10 kilometer the temperature would be constant. Very important line, you should remember. Now the inversion is produced by the absorption of UV radiation by the sun. So negative lapse rate is inversion. Keep this in mind. Inversion is when there is increase in temperature with increase in height, that is negative lapse rate, that is inversion. Alright, inversion is what? The increase in height with increase in temperature, but usually there is decrease in temperature with increase in height. Alright guys, if you're not getting, please let me know, because this is my first time teaching too, and I'm trying my best to make you understand. So yeah, this is so the clouds that are found in these layer is the nacreous cloud, also known as mother of pearls. Alright, not very important, you can just read all of these. Okay, so one thing that is this is a stable region, whereas these tropopause was unstable region. Now I'll tell you what stable and unstable is. That unstable is basically, wait, I'll explain you one. Okay, so this is the example. So this is the example of a unstable position. For example, if we leave this ball, it will go here and then probably come here. So stable is when there is ability of body to be, like, to come back to its position is stable. But unstable is that the body does not have the ability to come back to its normal position, is the unstable. So for example, if we take the example of flights, so flights should come back to the land, that is unstable. So troposphere is working very right, because the plane has to land some day, of course some time, but that is what troposphere usually it acts. The aircraft come back to its to come back to certain position, that is land, and does not stay in the air. That is what unstable region is. But stratosphere is that it makes hard for the aircraft to go back to some other position, but it makes the aircraft stay in their layer. That is what the stable region is. All right, you get now? So from this you learn that we need an unstable region to fly in, that is troposphere. So usually the flights fly in the troposphere region. All right, now moving on to the next layer, that is mesosphere. You can just read it all, not very hard. Extends from 50 to 80 kilometer. Very important, need to remember. And the cloud that is found in it is noctilucent. All right, very important. What was the cloud that was found in stratosphere? That is nacreous cloud, and that this one is, you can remember, mother of pearls, and this is noctilucent. All right, noctilucent is like it's night and night, shiny night light, something like that. You can just check the picture of it to remember it by the picture. Well, I have this habit of remembering things by seeing it, because it's quite hard to remember these names, but you can just remember by seeing. So that is how. Okay, so mesosphere is the do you remember we were doing that decrease in temperature, increase in temperature, then there's decrease in temperature, means the mesosphere, very cold, minus 100 degrees Celsius. Can you connect now? That is how it works. Then it is thermosphere, very hot. This is where ionosphere you will find. Ionosphere is above 60 kilometers. All right, these all you can just read, and if you don't understand, you can please you can comment down below. I'll surely revert back to you. Then there's exosphere, that is like the total different, like you can read it, it is the outermost layer from the top of thermosphere. All right, not very important reading about these spheres, but you can just read all of the spheres, layers, I mean. Now something that is very important, this is something that you have to remember. Even if somebody wakes you up at the night asking, I say you should know this by heart. Very important, read this. All right, now something that is, another thing that is important is this. It comes in exam most of the time, that is ISA. Deviation is actual minus ISA. Well, this is something that I would be explaining in the next class, because then the video will be so long and you people will be thinking that this madam said that it's not very hard in taking 50 minutes classes, 1 hour classes, right people? All right, now people, now I'll call you all pilots. All right, these are the important stuff. Another important stuff is this, that is JSA and ISA, jet standard atmosphere and all that. Now if you see, these are the questions, and I would be solving these all for you guys. Now this is the end of the chapter, and I hope that you wait. Thank you so much for staying till the end, and I would just want that if you have any doubts regarding the whole chapter, please don't be don't be shy to comment down below. I would be really helpful. I would be, sorry, what am I saying? Actually, I'm really bad at saying all of these, but never mind. Some quote that I have made for, like, not made, has got from this Google. It says, never quit, never give up, fly it to the end. And by this I would be ending my video. Like it, I mean, fine if you, even if you don't like it, but just I want you all to be pilots next day, sitting beside me, all right, in the cockpit. All right, bye everybody. All right.